to WASA Distance Education. This is MBF3C, Grade 11 College Prep Math. I'm Pete, and I'm your teacher. So welcome to our week 2 of semester 2A. So we're moving right along here. So we're going to finish up the lesson we were doing on Thursday, and don't worry, I'm going to back up a little bit, and that's kind of the way I do things. We'll back up a little bit and take another run at the factoring that we were looking at on Thursday. And I'm not sure, we should be able to get into it today. We're actually going to find out why we're doing all this, because we're basically setting up for something here. Okay, we've learned to use the distributive property with a monomial and a binomial, and with two binomials, okay, using FOIL. And then we started looking at how to factor a polynomial, actually a trinomial, which is the standard form of a quadratic relation or the equation of a parabola. Okay, so we're going to finish learning how to do those things, how to manipulate those formulas, and then in the next lesson we're going to find out why there's actually a point to this, and it's kind of a cool thing. So let's find out where we were on Thursday. Now, just as a little bit of a heads up, next Monday apparently is a holiday called Family Day, and so that should be. So we're not going to have class next Monday. That's basically the bottom line, and so you have a nice 3-day weekend. Okay, let's see here. So on Thursday we were looking at using FOIL to multiply two binomials together. So the two things in brackets, each one of those is called a binomial because there are two of them. And we just use FOIL to multiply those together. The process that I was showing you is that you use FOIL, and then the first step once you start with the FOIL is to figure out the sign. Okay, because if you figure out the sign first, then you sort of write it down, and then you're not going to have any problems with it. And then you can work out the actual numeric values or the variable values. Okay, so that's using FOIL. If you need to see more examples of that, feel free to just kind of speak up or contact me, because this is really a skill that you kind of learn by doing a lot of practice. Hopefully they've given you a lot of practice in the book, but maybe you need to see a few more examples. Okay, so that was the first bit. Now, when we use FOIL to multiply two binomials together, we end up with a quadratic relation, right? Which is just the equation of a parabola of this form. It's ax plus bx plus c. So it's different than the vertex form that we saw. And if you take a grade 12 version of this course, you'll probably see some work where we convert from one format to the other. In this class, we're not. We're just going to look at the standard form, and we did look at the vertex form, but we're not really going to work on converting them back and forth. What we're doing now is we're just kind of shifting now to looking at this standard form. So standard form, S-D-A and D-A-R-D form, okay. And like I say, that's what happens when you just multiply two binomials together, okay. So if somebody asks you to, show this in standard form, and there's two binomials, then what they're basically saying is use FOIL, okay. So that's the way that works. Now, we want to learn how to factor standard form, which is to undo multiplying two binomials together. Okay. So the way that works is that we assume that it's two binomials multiplied together, and we're going to undo it and figure out what the two binomials were. Okay. Because we know in the standard form, by the way, I guess I should tell you we're on page 16. Sorry about that. Yeah, we're on page 16. So we know that the B and the C come from the two numbers that we multiply together, right? This is our B. Oops, sorry, that's not sorry, that's not correct. There's two numbers here, right? That multiplied together give us the b. I didn't mean to put that b in there, because it's the two numbers multiplied together that give us the c, and added together to give us the b. Okay. So that's how we get the standard form. Now this factoring only works if the a in the equation is 1. So in other words, a is just x squared or some variable squared. They're showing it here. It's y squared. Okay. We don't write the 1, but there is a 1 there. Basically, we just assume that a 1 is there. Okay. Now, you may wonder why we do that, why we don't write the 1s. The problem is that just about every number that we use, every expression we use in math, has an assumed 1 somewhere in it. Exponent, if it's not there, it's assumed to be 1. The denominator, if in a whole number, is assumed to be 1. Right? The coefficient in front of a variable, the number in front of a variable, is assumed to be 1. So we're assuming 1 all over the place. And if we started writing it everywhere, then it would make our algebra very, very cumbersome. So we just assume it's there. And if you need to plug it in while you're doing solving an equation or something, that's perfectly fine. Right? You're allowed to do that. Okay. So we did look at how to do a few of these, and we'll do a few more. But I also want to mention that sometimes we're going to get them where a is not a 1, and then we have to factor the a out. And I think I just got started doing that on Thursday, and I may even have kind of, I think I might have even started on a little bit of a kind of a wrong foot there to try and explain that. Okay, so let's try a few of these then. This is question 6 on page 17. So it says factor completely. Okay, so we'll do a few of these from question 6, and then maybe we'll do a couple of the key questions, and then we'll move on to explaining why we use that factoring, because it is really cool. We're just winding up now to figure out why we're doing this. So let's see here. I think I did 5 last week, and well, let's try these two. We'll try F and I. Okay, so that's question 6. Support question 6 on page. I guess I should really find it here. Okay. So that's going to be page 17. So I'm going to do F and I, part 6. Right. Now I'm going to make a new page here. So this is support question 6 from page 17, and we're going to do F. Now F is as I say, you don't have to write out the question. In a case like this, though, it's sort of the first step, so that might be okay to do that. What I talk about writing out the question is if it's a word problem and says, Joe was down to the store or whatever, and so I just don't want you wasting time writing that out if you don't want to. You're welcome to do it. So I have f squared minus 2f minus 8. Now the thing to notice is that there's no number in front of the f, so that's a 1. So it's in the proper form to just go ahead and do this factoring. Okay. Now, if you remember what we need to do here, we have to look at these two numbers, including the sign in front of them, and come up with a pair of values that gives us those two numbers. Okay. So let's see. So 1 times 8 gives us 8, and 2 times 4 gives us 8. The nice thing about 2 and 4 is that there's a gap of 2 between them, which satisfies that second, the middle term, right? So I think we're onto something. So it's going to be this, but now we have to work out the signs, because it could be minus 2 and 4, or it could be minus 4 and 2, right? So both of those pairs give us the -8 that we're looking for. So let's turn our attention to the -2. We have to be able to add those together and get a -2. Well, -2 plus 4 gives us +2, which is not correct. But -4 plus 2 gives us -2, and indeed that's the one that we're looking for, right? Okay. So now we're just going to write it out. Okay, I guess I have to use another line here. I would normally just do it on one line. So it's going to be f times something, and it's going to be f times -4, and then f minus 4, f plus 2. We just plug in the two numbers that we came up with, right? Okay, we just plug them in to this to the equation as if it was the two binomials being multiplied together. Okay. Now, just to be really clear, and this might be obvious, right? It actually probably is obvious to you, but I'm just going to show it just to say that, all right, we've been through this. Okay. All right. Let's check. Okay, you don't have to do this part, but let's check. Okay, let's just multiply the two of them together. F minus 4, F plus 2. By the way, it doesn't matter one bit whether you put which order you put the two numbers that you come up with in. It could be F plus 2, F minus 4. As long as you get the signs right, it'll work out no matter what. All right, so we're going to use our FOIL now. So the first one is F times F, which is F squared. Okay, and that's a lousy looking F. I'm going to try that again. Okay, so F squared. Well, I didn't do any better. Okay, so that's the FOIL F. Okay, now, so F-O-I-L. Okay, so I've done the F part. Now the O is the outside, two outsides. So positive 2 times F is going to be 2F. Inside, which is -4 times F, so that's just -4F. You'll see that there's a pattern to this, right? And then last is going to be -4 times positive 2. The signs are different, so the sign of the product is going to be negative, and then 2 times 4 is 8. Now, we're going to combine like terms. This is our next step. It's called combine like terms. Okay, and when we say like terms, what we mean is not that you like the terms, but rather they're alike. This is like pairing socks, really. You know, some of us pair socks, some of us don't. So let's try it. So we have F squared, because there is no other squared term. Okay, we can't find another match for this sock, so we just have one of them. But for the middle two terms, I got a 2F minus a 4F. Well, 2 minus 4 is -2F, and minus 8. Okay, now let's double check. Let's take a look at how this compares to the original equation, and indeed, there you go, F squared minus 2F minus 8. Okay, so we've confirmed that our factoring worked, and it's always going to work if you use this little process here. Now, it's as far as doing this part on the side, that's pretty standard in mathematics. So if you do that, if you put that kind of scratch work on the side, you don't really have to say what you're doing, because everyone's gonna, anybody that has studied this will know what that is. Okay, so you don't really have to. I mean, you could say, find A and B, or find B and C, but you don't really have to mention that. Okay, so we did question F, and then I said I was going to do part I. So I'm just going to extend this page here. Now, part I is a little more complicated because it has a coefficient, a number in front of the variable. I'm going to show you how to deal with that. Okay, double check. So 3b squared minus 24b plus 45. So let's make really, really sure we got it. It looks like we got it. Okay, gonna check here real quick. Okay. So we're going to end up with something in the format b plus or minus something times b plus or minus something. But before we can do that, we have to put it in a form where that 3, it's going to go away. Okay. So what I'm going to do here is I'm going to factor out a 3. Okay. So if I was to write this 3 times b squared minus 24, you know what? I'm gonna show this a slightly different way. Okay. Let's say I had something like this. Let's say I had 25 plus 5. You're not going to have something like that, right? I could actually rewrite this as 5 times 5 plus 1, right? I basically divide both of these by 5 and then multiply the whole thing by 5. Okay, that's basically how it's going to work. So we're going to do the same thing for I over here. Okay, we're going to multiply the whole thing by 3, and then we're going to divide each of the terms by 3. Okay. Now, once you get started doing this, there's a very good likelihood, very high likelihood, that you probably won't necessarily show this step because it's usually pretty straightforward. But when you're just getting started, you want to do as much as you can here. The problem with showing this notation is it could be just a little confusing because the next step, you got to remember that your whole point is to keep this 3 out here. Okay? That's your whole point here. And the reason you want that 3 is you want to be able to cancel these 2. That's all. You don't care about canceling the rest of them, just the one in front of the first term, the squared term. Okay. So we still have 3 times. Now what do I have? I have b squared because we got rid of that 3 over here. This 3 goes into 3 once and into 24 8 times. So, and it's going to be minus 8b, and the reason is we still have that negative sign there. Okay. And oh boy, did I ever mess this up. Sorry about that. That was supposed to be a 3. I hope y'all either caught that or it's not. Okay. All right. So if you rewind this tape or replay the video, then you'll see that I made a mistake there. Oops. All right, so let's see. 3 goes into 3 once, and let's see, into 4 once, into 15 5 times. 5 times 15. So, and that's going to be plus 15. So plus 15. Okay. So there we are. How did it work? Let's see. So I'm checking my work here because I just want to make sure that's the only mistake. Yeah, that's the only mistake I made. Hopefully. All right, I'm just going to extend the page a little bit. So the idea then was to write this out with putting dividing each of the terms inside the brackets by the number that we factored out. We factor out a 3. I'm going to divide each of the terms by 3. Okay, and it's that simple. Okay, so now we have this inner part in the format that we need. Now, the reason we can do this and it doesn't affect our ability to then factor this is that factoring out that 3, basically what we're going to do, well, you know what, I'll explain that in the next lesson. Sorry, I was a little over eager here. I was going to get ahead of myself. But anyway, now that we've done that, we can forget about the 3. We just leave it as part of the work. But now we can factor the part in the brackets as we always do. Okay. So what I'm going to do, I'm just going to rewrite this over here. It's not strictly necessary, but I think I'm going to run out of room if I plus 15. Okay. So now we're looking for, we want to write b times something, b times, or plus or minus something, b plus or minus something. So let's take a look at what we got here. We have a negative 8 and we have a positive 15. So again, I'm just going to go off to the side. Well, I know that 1 and 15 works. I know that 3 and 5 works. And 3 and 5 is actually kind of nice because they do add up to be 8, don't they? All right, so how can that work? Um, okay, well, if they were both negative, then I think that would work because negative 3 times negative 5 is positive 15, so that's good. And then negative 3 minus 5 is equal to negative 8, which is also good. Okay, so I think we got this. So let's give this a go. So it's negative 3 and negative 5. Okay, that's it. Oh, okay, sorry. So, hey, who do we have from Wagamon? Is that you, Charlotte?
Yep.
Oh, how's it going anyway?
Good. I'm listening in from home to the radio.
Okay. Are you able to follow what I'm doing right here? Because I kind of I'm not showing it. Oh yeah, you're listening through the radio.
Yeah. What lesson are we on now?
So we're on lesson 2.
2?
Yeah, and page 17. Okay.
Okay.
And so what I'm doing is I'm going through support question 6 I right now. Now, do you have a way to watch the YouTube videos afterwards?
Yes.
Okay, so that might be a good idea. I'm working really diligently to get those posted, within an hour or so of when the class is over.
Okay.
Okay, so you should be able to watch that.
Okay.
All right, great. All right, good to have you on there, Charlotte.
All right.
So this is what I think we pretty well wrapped up question 6, part I. So what I'm showing you then is, in this case, it's a bit more complicated than the other ones because we had to get rid of that 3 in front of the variable first, the squared term. And in the end, it didn't really change anything. If we multiplied this out, what we have is 3 times b minus 3 times b minus 5. And if we multiplied them out, we could actually multiply the 3 by the first term if we wanted to, and then multiply the resulting binomial by the second term using FOIL. Or we would multiply the two binomials together using FOIL and then multiply it through by 3. That's my preferred method, but really it doesn't matter. If you have 3 numbers to multiply together, you can do it in any order you want, okay? Because multiplication, there's no order. It'll work no matter what order you use. So, okay, so that was it for the support question. And in fact, if we go back to page 17 here, key question number 2, I think that everything should be pretty straightforward there. It's the first question. Well, it says for questions 1 to 4, it says expand and simplify each expression. So expand means FOIL, yeah. And then simplify really means combine like terms. Which I don't really, I mean, to me, it's just, it's all just one thing to do, right? You're going to use FOIL, and as part of FOIL, you're going to combine like terms. I don't really see that being 2 steps. But anyway, so they've shown us how to, they've given us a bunch of practice to do. Now, let me show a couple of these, kind of point them out here. So question 1, they all look pretty straightforward, I think. Don't let the ones like 1D throw you where the variable's not x. It can be any variable, okay? The other one is that things like C, question C, where it's negative x plus 7, so you have to watch things there, right? But, you're going to end up with, so you do your FOIL, it's negative times a positive. The result is going to be negative. So now I have x times x, which is x squared, and then you can proceed like that, right? So if you work out the sign first, you're going to be fine. Just look for things like that in front of the variable. And then the other one, f, looks a little strange. It's x minus 9 squared. What they're really trying to tell you there is that this is an x minus 9 times an x minus 9. Now it looks like something we've dealt with in the course material, right? So, and now you're off to the races here. Okay. Now, for question 2, you'll see that they have the number in front. I would just go ahead and use FOIL on the 2 binomials, and then you're going to end up with 2 times something in brackets. and then use the distributive property to multiply each term in the brackets by 2 in that case. Okay, and to me, that's the easier way to do it. And you'll work that out by working out the sign first of each term, and then the number. Okay. All right. What else? I think that's good. Question 3C will be a little tricky just because they have 2 variables. Wow, that is a pretty hardcore question there. But you'll work on it exactly the same way as you normally would do. Okay. Question 4 C is also that's pretty serious business here, because you have a variable as the number you're going to multiply things by, and it looks really kind of frightening there. But if you use your FOIL, right, on the 2 binomials, and then you multiply negative d by everything inside the resultant brackets, it's going to work out. Okay, and so let's take a look at this one just a little bit here. This is key question 2, and this is going to be 4C. Okay, so 4C. All right, 4C. So the question is negative d times 2d minus 1p. See, part of the thing is, I don't think that this was really covered in the course material, but I think we can deal with it. Okay, let me make sure I got this. Minus 1p. Now, I'll tell you right off the top that this this expression, negative 1p, that's not how it would normally be written. It would just normally be written p. So I'm not really sure why they did that. I suspect that it was probably originally some other number and someone came along and edited it. But anyway, this is what we got. So the first thing I'm going to do is I'm going to multiply the 2 expressions in brackets using FOIL, and then we'll multiply the negative d. So let's not forget the negative d. We're going to need it down here. Okay. So FOIL. Okay, I don't know if I'm actually going to do the whole thing here, but so the first part we're going to do is we have 2d times negative 3d. Now first we're going to do the sign. The signs are different. The answer is going to be negative. Now I have 2 times 3. Well, 2 times 3 is 6. And I have d times d. Well, d times d is exactly d squared. See? All right, so far so good. So that was the F. Now we're going to do the outside one. I'll change to red. So we're going to do 2d times negative p. Well, this is going to be interesting. So the signs, I have a positive times a negative. The sign's going to be negative. I have a 2d times p. Well, I'm going to write 2dp. Okay. Now you might ask me, well, why didn't I write 2pd? Well, the general format for something like this is to do an alphabetical order, right? And it actually will make sense when you see the next one. It'll make sense to do it in alphabetical order. So we've done the O. Let's do the I, the inner 2. So I have a negative 1p times a negative 3d. Well, let's get the signs. I have a negative times a negative. It's going to be positive. I have a p times 3d, which is going to be 3dp. Now, if you look at this term and the one preceding it, I have negative 2dp plus 3dp. Now I can work with them. We can recognize them as like terms. If I didn't put them in alphabetical order, we might have had a dp plus a pd, which, even though they're the same terms, not quite as easy to recognize. So I suggest you put them in alphabetical order. And then our L, I have a negative 1 times a negative p. I have a negative 1p times a negative p. Negative times a negative is going to be positive. P times p is just p squared. Okay? And then we close out our bracket. So you're going to, next step will be to combine like terms, and then you're going to get another expression, something multiplied by d, and you're going to use the distributive property, multiply everything by d. Now the terms that have d in them, like d squared, will just go up by one exponent, so that the negative 6d squared will end up being positive 6d cubed. And then the middle expression, whatever that ends up being, will be d squared p, right? And then the last term, p squared, will just be p squared, will actually just be d p squared, right? Okay. So do your best on that, and it's always an option to once you solve something like that, just to send me your answer, and I can look it over. Be happy to do that. Take a picture of it, send it to me, and yeah, I can tell you how you're doing with that. Okay. So the other one I'm going to look at here is question 5. These are the key questions. Oops. So this is page, where are we here? It's going to be page 18 of Unit 2. And key question, key question 5. Again, this is not really something that they did when you were in the unit. So it says, write a simplified expression for the area of each object given below, right? So if this is the length and this is the width, then the area of this is just A equals LW, right? Well, you're just given a variables for the length and the width here, okay? Which is a pretty common thing in manufacturing and stuff like that. And so really just you're going to write the area formula, substituting the algebraic expressions, 3x minus 7 for the length, 2x for the width, and then just multiply them together. Simplify the expression. It doesn't really say it, but simplify the expression. Okay. Now, for a square, which is part B, the area of a square, it's been a while maybe, it's just s squared. So it's just the side length times itself. You're given a side length 4x minus 3, so you're just going to write 4x minus 3 squared and then solve that. Okay? All right. Question 6, it says, given this expression, explain in words the steps taken to completely simplify the expression. So basically what they're asking is, you're going to use FOIL, and then you're going to combine like terms. Okay. I just want to point out, this is worth 5 marks, and it's a bunch of words. So, write down 5 marks worth of words. Probably, I would say 5 sentences, and then plus an introduction and a conclusion. So maybe 7 sentences, kind of at a minimum, to get your full 5 marks. Okay. I just want to encourage you to try. I'm not going to get all worked up about your spelling, grammar. I mean, it's important, but the most important thing, and what the 5 marks are really for, is your explanation. Show me that you understand the course material, how to do this. Okay. So there we go. So that's a 5 marks. I think we got everything, and then factor completely for number 8. So that was what we were just working on today. And I think you're actually, I think you're off the hook here for working out that A, or factoring out the A, because it's not in any of those. Is there a 9? No. Wow. Okay. So now we're on to lesson 3, and that's great, because this is really where we're going to figure out why we were doing all this factoring. Now, you'll be using this idea quite a bit as if you are going to college, taking college math, even in grade 12, the grade 12 version of this. The idea is that when we have an equation in standard form, one of the things that we can look at remember that what we actually have here is a parabola. Okay, and one of the things that's very useful to know is where that parabola crosses the x-axis. It's a very, very useful thing to know. Um, because in a lot of cases, in business functions and things like that, that's right. Maybe this is your break-even point. And of course, I've used the same color here. Maybe this is the point where your product starts to make money, or this is the point where your your chemical process is correct, or something like that. This is where the parabola or this equation crosses the y-axis is, or sorry, the x-axis is usually an important point in um, in the equation. Right? That's an interesting place. So it writing the equation in standard form and then factoring it gives us a very easy way to find these 2 points, and there would generally be 2 points. Okay, the only exception is when the parabola has a vertex that's 0, 0, and then there's only 1. And again, I managed to write the parabola with the same color as as the axis. Okay. So when we're solving a quadratic equation, and this is, by the way, this is on page 20 of your Unit 1, so this is lesson 3. So when you're solving a quadratic equation, this is called finding the zeros or roots. Okay, I'm usually going to call it the roots. Okay, and it is basically what we're trying. This is the y-axis. So if you think about it, the x-axis is the line where y is equal to 0, right? So if we have this equation here where it says where we have y equals x squared minus 3x minus 10, okay, then when y is equal to 0, okay, that's where the parabola has crossed the x-axis. It's going to do it in 2 places. So it's up to us to find basically all of the cases, all of the x values where y is equal to 0. Okay. So, and as it so happens, if we factor the quadratic equation and then set each one of these to 0 one at a time, then those are the 2 places where it crosses the x-axis, right? So if I have x minus 5 and I set that to 0 and then I solve that for x, right? I have x equals 5, right? Because we take the minus 5 over the equal sign, okay? And x plus 2, I solve that for 0, and x minus 2. So the places where the y value is equal to 0 when x is equal to 5 and when x is equal to negative 2. Well, if I was going to plot this on a graph, this is my x, this is my y, basically this is going to be 5 right here, and this is going to be negative 2. Okay, so that tells me something about the parabola. Okay, it tells me how far it shifted over, and it gives me an idea of where it crosses over that x-axis. Okay, we can actually use this idea to solve for other values of y, not just 0, but usually we're finding the roots, which is the zeros. Okay, and that's really what someone says. Find the zeros of this equation. That's really what they mean. Okay. So now here's an example where things are not quite as straightforward. Okay. It's possible to use the factoring method that we used before. Okay. But in fact, there's a simpler way to factor this, right? We could factor this by saying, all right, I see that we have 3n, which is a common factor of both of these terms. So let's factor out a 3n, okay, and then figure out what we have. Well, 3n squared divided by 3n, minus 6n. By the way, it should be, whoops, okay, I made my n in a funny way. It should still be possible to factor this the standard way, but we'd actually have to start by factoring out a 3. So minus 6n divided by 3n. Okay, so we did that. That cancels, and what's kind of interesting is one of the exponents cancels, okay, and then that cancels, and we end up with a 2 right there, which means that it's 3n times, what do we have, n minus 2. Okay. Well, now it's factored. We have two things multiplying together, and we can actually solve for each one of these, right? We could now set each one of these to 0, 3n equals 0. Now, a traditional way of doing this is to sort of put them on the same line and solve them in a kind of parallel way. Now, for the left-hand side, n, 3n equals 0. 0 divided by 3 is still 0, so our answer is 0. And that's just something you'll learn to recognize. And here it's just n equals 2. Okay. So again, you really don't have to explain this as you're solving this sort of thing, because finding the value when each term is equal to 0, term in parentheses equal to 0, is a pretty standard thing. And the way I've shown you how to do it just down below is pretty much the way it's done. Okay. So if we were going to graph this, then we would basically have, in this case, it would be y and n, not x. It would be y and n. And let's see, how would it look here? So one of the roots is at n equals 0, and the other one is at n equal 2. So, and it looks like it's positive, so there you go. So it's something like that. Okay, so that's going to be a 2, and that'll be a 0. So that's what the parabola looks like. And, you know, someone can figure something out about that. Okay. Maybe it's a chemical reaction. Maybe it's a bacteria culture. Or, you know, a lot of business models do that. Okay, and so they show it. So here's an example here. Example 3. Rock is thrown straight down from a building 95 meters high. So you know what? This is not the CN Tower. I think the CN Tower is a little higher than 95 meters. Maybe it is. But anyway, it's just a building, right? So let's see if we can sort of figure this out. So somebody's up here, okay, and he's got a rock, and he's going to throw it straight down, 95 meters. Okay. So in the relation h equals negative 5t squared minus 25t plus 95 is a model that gives the approximate height of the rock in meters. Okay. How long does it take the rock to reach a ledge 25 meters from the base of the building? Oh, look at that. Okay. Right about there, I think. Okay. Now, I believe that there's a mistake somewhere in this solution. Okay, and there's a mistake somewhere in here. mistake. Okay, so watch it. It doesn't. I don't think it's. There's. We'll work it out as we're doing our. Yes, I think I see it right here. This one's good, and then I think things kind of go kind of ugly here. Okay. So what they want to know then is how long does it take the rock to reach this ledge? So this ledge is 20. This is 20 meters right here. 20 meters. Okay. Whoops. All right. Well, we meant that. This is our ledge. Okay, so the rock is not actually going to fall 95 meters. It's actually only going to fall 95 minus 20 meters, which is 75 meters. Okay, so that's where things kind of get a little bit kind of messy. All right, but it's okay. We can still do this. So what we're saying then is Normally we want the 0, but in this case, this is h and this is t, and what we want to know is when does a parabola cross the 20 line. Okay, that's basically it. Yeah, yeah, this should be t along here. This is time. Oops, time. And in a case like this, we really just discount it. We'll still draw it or whatever, but we discount the negative t values because, it doesn't make any sense. Okay, we always end up with 2 roots for these parabola solutions, but if we're dealing with time, one of them doesn't make sense, a negative time. Okay, so let's see. Okay, I think we're ready to try and solve this. So I'm going to have to open another page here. Okay. All right. So this says example 3. So this is page 21, example 3. Okay. So we have h is equal to negative 5t squared minus 25t plus 95. Okay. Now the thing is that we don't want a 0 h value. We actually want to solve it for the case where h is equal to 20. Okay, right? So up until now we've been solving it to find the 0, but it actually works out well. What we can do is we can move this 20 over to the other side here, right? By subtracting 20 from both sides. Okay, and so now we're back to pretty much what it would normally be. We have to simplify this little part a little bit, but that's okay. 0 equals negative 5t squared minus 25t plus 75. There we go. Okay. So now we're ready to find the value of t that makes this whole equation true. Okay. But we got a problem because, as you see, we got the negative 5 there. So let's factor out a negative 5. Now, I showed you before where we just put a negative 5 in the denominator of each of the terms in there, but let's try it without doing that. Okay. So the first one is just going to be t squared because that's the whole point, right? Now, if I divide negative 25t by 5, right, I should end up with plus 5t. Does that make sense? Because if we did negative 5 times positive 5t, we'd end up with negative 25t. Okay, right? And this was a bit of a mistake here. 5t. Okay. And similarly, negative 25. Okay. Right, so 75 divided by 5 goes once, 15, negative 15. Okay. There you go. And there's the error in the, if we back up now, there's the error in this. Okay. They have negative 14. There's no way you can get that because you're working with multiples of 5. Okay. So that's the error. It should be negative 15. Just a typo. Very common in math textbooks. So that's why I always suggest that you work through these examples with a pencil and paper, not just read them, but work through them. All right, so this is what we got. So now we factored this, and now we're ready to factor this inner part here and factor it in our usual way. What we're looking for are pairs of numbers that give us negative 15 when they're multiplied and plus 5 when they're added. So 1 and 15, certainly. 3 and 5, certainly. that's pretty much going to be it. Negative 15. Let me just check here. 15, yeah. Okay. It's 25. 3 and 5. That doesn't work. Okay. 1 and 15 doesn't work. 3 and 5. Any other factors of 15? Okay. All right. I think I'm missing something here. Okay. I might have to think about this. Let's see. What else do we get? Okay. Minus 5. I'm just double checking my math here. T squared plus 5t. Yeah, 25t. Okay. Oh, there it is. Indeed. So basically, what I found here is that I can't actually solve this, which means that what does it mean? Okay. Anyway, the reason I can't solve it is that there is a mistake here. Okay, I think the mistake. Here it is. How long does it take the rock to reach a ledge 25 meters from the base of the building? Right, 25 meters, not 20 meters. Okay, so this is written up as if it was a 20 there. So let's try it. Let's substitute the 25 in here and see how this works. I actually have the error written down somewhere, and I'm apologize for not having it handy here, but it's kind of useful to, because we know we got a problem. It's either, something's wrong with the question here. So let's try it with, oops. Let's try it. Only got about a minute left, and I'll come back and have the answer for you tomorrow. Let's see what happens when we make this 20. Whoops, when we make this 25. Okay, so now this is going to be 25 instead of 20. So that's going to be 70 here. Okay, and then when we divide 70 by 5, 70 divided by 5. Oh, look at that. We get 14. Aha. Oop. All right, let's try it again. We have 14. So indeed, so the mistake turns out that it was not the 14. So this was actually correct. It was this. This should be 25. 25 here. Okay. All right, and then you can see the answer that they got. Okay, so let's go back here and see. I need, so 2 and 7 gives me 14, 1 and 14, but the 2 and 7, now you can see we can get the 5 out of the 2 and 7. I better wrap it up here, but you've actually got an example of how we always have to check things in math, and if you get an answer that doesn't make sense, it's not necessarily going to be you that's doing something wrong. Okay, you just got to go back and check whether or not it's a valid question. All right, we'll pick this up again tomorrow. And all right, well, thanks for joining us.